Hello, today we will start a Python from zero, and I think the easiest way is to type Google Colab on Google search and then just open the first tab and then just click open new notebook. So it opens up a Google Colab. We can close this window right here and then we can change the name to whatever we want, to hello 02, for example. And these little rectangles are what's called cells. They run independently. It's like having a little Python program just in this cell. And we can have multiple. We'll see when we get going. So we will start with knowing what variables are. So a variable is a name that points to a value. So for example, name equals Luffy. Here, the important thing is that this equals, it's not like in math, this is equal to this. In Python and in many other programs, the only one equal sign is an assignment. This string is will be stored in our memory somewhere, and in order for our program to access that memory space and bring what's in there, it's assigned this name. This name points to the memory places where Luffy is stored, so we can access it. So in order to do that, we run this cell and then we can, for example, print name. When we run this cell, it prints Luffy. The nice thing about these Jupyter style notebooks is that you don't need to print name to see what it points to. You can just put name and then run it, and it gives us what it points to, and it points to a string Luffy. But back to normal Python. So print, and then let's say I put it in quotes, name. If I put this in quotes, now it takes this as a string, not as a pointer to a variable, not as a variable name. So if we take this off and now run it, it points to this string which is stored somewhere in our memory, and we can access it through this variable name. So let's remove this cell and let's remove this cell and add a new one. So let's do another variable now pointing to an integer. So bounty equals 50 berries. We run this, and now bounty, we run it, 50 berries. We can print bounty, run it, 50 berries. Now we can change variables. So for example, now 30 values, we run this. So now if we see what's stored in the bounty variable, now it's 30 berries, not 50. So what happened here is we placed the value 50 somewhere in memory and we assigned it to a pointer named bounty. Then we stored 30 somewhere in our memory and assigned a pointer named bounty. So now, since it's so this overwrote what this pointer was pointing to. So this 50 somewhere in memory, but now we cannot access it. So it lost its pointer because the pointer was reassigned to a new integer, 30. All right, let's erase this. So as for variable names, we can use, they cannot start with a number. It will shout at me. Yes. They cannot have, I think it cannot have hyphens either. Nope. So we can do underscore equals whatever. So this ran, so it's okay. And we cannot have some reserved, like some reserved names like this one. It will shout at me, yes, because class is already a Python reserved, and there's a whole bunch of these. I don't know them, but so the types of values we can store in memory and access them through a name, which is what we call variables. The types of data we can store are integers. We already saw them, like bounty equals 30. And then we can store strings, like we already saw this one. These have to be around quotes or single. Other name is we can store also floats. My float equals 0.85. And there's also booleans, like is true equals to true, and is whoops. Well, it has an autocomplete, and then it auto put to print all of this. Colab did this all by itself. I did not know that, but that's cool, right? So then let's run this cell, and there we go. It printed this. So why are these is true and is false used to? Well, they can only hold, the boolean can only hold true or false, and that is very useful later on, because we can set variables to do things or not do things according to whether a value of some variable is true or false. We can check out the type Oh, how do I make this autocomplete all this. There we go. So it kind of knows what I will do, right? Okay, so we can print out the type of the variable and run this cell here. Class int string float bool. This class int is because everything in Python is an object, and objects are made with classes, and we will learn about those like in 100 videos later. There is also like a special type which is none. Equals none, like this. So if we treasure, we run this, did not output anything. So print treasure, printed none, print type, let's print the type, class non-type. Okay, these are sometimes useful because when we search, sometimes we search for something in a list or on a dictionary, which we'll learn what are those later. And if it does not exist, it may assign this non-type. And of course, they are case sensitive. If I try to print, instead of name, with upper, it will shout at me because name is not defined. Like this also is not defined. So it is important. Variables are case sensitive. There you go. So something important about variables or types. For example, A equals 20, B equals 30. And then if we add them up, A plus B, and we run this, A plus B, it's 50. And we only got away with this to showing this because it's a Jupyter. In regular Python, we would have to have assigned this result to a variable like total, and then later print total, like this. All right, but what happens if we put this around quotes? What do you think will happen? Because now 20, since it's around quotes, it's no longer an integer or a number. Now it's a string or a word. It's text. So this is something interesting. When we add two strings, this symbol changes meaning. Now it's not add like in math. Now it's the same as concatenate. So let's see what happens. We run this. Didn't shout at us, but then when we print this, boom, concatenated two strings. There are some more sophisticated type conversion stuff. Python. So now we can say a equals int. Int is a method or a function. We will learn about those later. But a. Then b equals int b. So int a, it's converting a to an int and then assigning it to a variable called a again. So we are replacing this one. We can put this c and then this one d. So a converting to int, placing it on c, b converting to int, placing it on d. Run this. Did not shout at us, so it's cool. And then we check what c means. 20. Okay, so now c plus d. Now we get 50 because it changed this. Now it can only change what resembles a number. If we put here cat, it will shout. There we go. So one thing that's a little bit counterintuitive, or it was for me, or it still is for me, is this. For example, a equals 20, and then b equals a. Right? Let's run this. No shouting. We cool. So a 20, b 20. Okay, but then what happens if I now, for example, a equals 30, and then what will be b? Boom, it is still 20. So what happened? We entered an integer and stored it in memory and assigned a pointer to this number 20. Then we assigned the value of a, which is a pointer to 20, to b. So now b points to a place in memory where b is stored, right? So now we stored in memory a completely new integer, 30, and then we assigned it to a variable or a pointer, and we named that a. So we replaced this a. So now this a does not point to 20, a points to 30, but b is still pointing at the prior value 20 in memory. If we a still now points to 30, which is somewhere else, and b points to the same 20 we had before. So that's it for this one. Okay, so I think that's it. Thank you for watching this short video. See you in the next one. Bye.